Assalamualaikum and hi, we meet again now in subtopic 3, which is 2.3 absolute values. So absolute values, or what you have heard before, modulus. And then for this one, we will go through again equations and also inequalities. Okay, so we can see the symbol, okay, absolute values or the modulus. So now first we need to know what is the definition of absolute values. So absolute values is actually either a positive of the function or a negative of a function inside the modulus. So if we have modulus of x, we have either positive x or negative x. So positive for x greater than or equals to 0, while the negative is for x less than 0. Or the modulus itself is actually a distance, definition of distance. So it is equal to set of x squared. Whatever the function inside the modulus, we need to square first and then we take the square root of the squared function. Okay, the second one, we also have some properties of absolute values. You can see all the properties of absolute values here in the table together with the examples. I think you can go through it all by yourself. Okay. So we're just going to go through the methods to solve the first one, which is absolute equations. We go through first the equation with equal symbol, okay, equal sign. So equations is a lot easier than inequalities, of course. So we go first equations. So to solve equation with this type of question, okay, we can either use basic definition or squaring both sides. It doesn't matter. Okay, so while going through the examples, we will see how we use both methods to solve the equation. Okay, so first off, we go to example 12. Okay, part A, solve the following equations. So modulus x equals to 4. So first they ask us to solve this by using basic definition. Remember, basic definition, we have positive and negative meaning of modulus x. So I rewrite modulus of x equals to 4. So the modulus here is actually positive or negative of x equals to 4. So first we have the positive of x equals to 4 and another one is negative x equals to 4. So the first answer is x equals to 4. Another one will be x equals to negative 4. And then we are done. So it's easy, right? Next one, part B. They ask us to solve this by using squaring both sides method. Okay. So I rewrite the equation first. X plus 8 modulus of x plus 8 equals to 2. So to use squaring both sides method, we have to use the second definition, which is the distance definition. So first, we use the definition of distance. So for the left side, the modulus is actually the distance, which is x plus 8 squared and then square root. Okay, so this is the definition of modulus. And then in order to cancel off the set outside, we have to square both sides. Okay, so then the set will be cancelled off. And we are left only with x plus 8 squared equals to 4. So for the left side, we need to expand it. We will have x squared plus 16x plus 64 and then the 4 equals to 0. So x squared simplify 16x plus 60 equals to 0. So this is a quadratic equation. Factorize x plus 10 times x plus 6 equals to 0. Then we have x equals to minus 10 and the other one is minus 6 and we are done. So this is the equations, absolute values equations. Now let us go to absolute inequalities, which is a bit difficult than equation. Okay, so we have two methods again, by using basic definition and also squaring both sides. But not all inequalities, absolute inequalities, we can use both methods. Okay, there are some we cannot use squaring both sides. So we have to use basic definition and so on and so forth. Okay, vice versa. And then we have a tip here. Okay, we can use go. So what is this for? So if the question is using greater or equal inequality, so then we have to combine the answer using or. But if the question is using the less than or equal to inequality here, so then we have to use and or intersection to combine the answers. Okay, so remember goal. You have goal, goalpost. This stands for the modulus, and then we have goal. Okay, so this goal only can be used to solve absolute inequalities by using basic definition. Okay, so we have absolute inequalities. If you can see here, we have type 1, we have also type 2 and type 3, where will be explained when to use basic definition, when can we use squaring both sides. Okay, so the first one, okay, look at the first one here. I highlight. If we have an absolute function on the left side and only one constant on the right side, we can use either basic definition or squaring both sides method. Okay, linear function of in the modulus in the left side. Okay, but if we have a quadratic expression for the modulus, so we can only use basic definition, not squaring both sides. Okay, so only basic definition. Okay, so let us go to example 13. So solve the inequality modulus 2x plus 3 less than 5. Okay, so by basic definition, when we said basic definition, of course we have positive and negative. Basic definition is actually we are using the separation of positive and negative of the function. Okay, so here, if we use basic definition, it means that we are going to use go. Okay, basic definition, we are going to use go. Okay, now from the first question, from the question itself, modulus 2x plus 3 less than 5, I rewrite it. 2x plus 3 less than 5. So if you see the modulus part is only on one side of the inequality, so then you can apply the goal. Okay, so we can see here it is less than, so less than meaning that we are going to use and. So of course, first we are going to separate this inequality into two, which is one positive and the other one is negative. So I put and here straight away, and or intersect, the same thing. Okay, so first the positive one, so modulus 2x plus 3, 2x plus 3 less than 5, it is the positive one. Okay, another one is for negative, so negative 2x plus 3 less than 5. So we need to solve each of these inequalities separately. So here we have 2x less than 2, then x less than 1. Settle for the first one. Okay, for the second one, it's either you want to expand the left side or you want to multiply both sides by negative. So we have 2x plus 3 when we multiply both sides by negative. So the symbol automatically will be changed. Okay, and then we solve this. So x greater than negative 4. Okay, so now as usual, I'll be highlighting my final answer for these two inequalities first, okay? Now I need to draw my number line in order to combine these two answers, okay? Draw my number line, put the -4 and then 1. So for the first one is x less than 1, open circle, less than 1. Then the other one, open circle, greater than -4. So since we are going to use AND or intersect, then we have to find the intersection of both lines. Okay, so we'll take the answer. If in solution set, x, where x is between -4 and 1. So we are done with the question by using basic definition. Okay. Now let's go to squaring both sides. I'm going to use different color. Okay. So by squaring both sides, at first I rewrite the equation. So modulus 2x plus 3 less than 5. Same as what we did before. First, we have to use the definition of distance, which is 2x plus 3 squared and then the square root. Okay. In order to cancel off the square root, we have to square both sides like this. Okay, so then we are left only 2x plus 3 squared less than 25. So I expand this, we have 4x squared plus 12x minus 16 after we gather the 25 to the left side, and we get less than 0. We simplify it some more. We divide both sides by 4. So we have x squared plus 3x minus 4 less than 0. So I think you should be familiar with this. This is inequality of quadratic equation. So as we learned before in part 2, when we have a quadratic inequality, we can use graphical method. Okay, graphical method. So here we first have to factorize that quadratic expression. So x plus 4, x minus 1 less than 0. So I have my critical values here, which are -4 and 1. Okay, then I'll draw my quadratic graph. So here is -4 and here is 1. Okay, now I highlight my last inequality here. So here I want the one of less than 0. Okay, the one with less than 0. Okay, here less than 0. So it means I have to take the one below the line. And so the answer will be between -4 and 1. This is in interval notation. So we have the same answer but in different forms. Okay, so we are done with example 13 by using both methods, basic definition and squaring both sides. Do remember, using basic definition, only we can use the goal. Okay, so why don't we then go to example 14? Okay, so 14, it's the same equation with different sign. Okay, here we have greater than 5. Earlier we have less than 5. Okay, don't worry. First, to use basic definition, I rewrite the equation, the inequality again. Okay, but this time it is greater than. So greater than is or. So I should separate them and use or. Or is union. So here, the same thing. So 2x plus 3 positive greater than 5. And another one is negative 2x plus 3 greater than 5. So for both inequalities, we have 2x greater than 2. So x greater than 1. This one is 2x plus 3 less than negative 5. 2x less than negative 8. So x less than negative 4. So I'll be highlighting this again. Okay. And I have to draw my number line in order to combine these two answers. So I have negative 4 and 1. So first, greater than 1, it's open, okay? It's an open circle, greater than 1. And another one is less than negative 4. Okay, so now here we have union. Union means we have to take all the lines, okay? So I'll take all the lines here and here. So the answer should be in solution set x, where x is less than negative 4 or x greater than 1. And we are done by using basic definition. Okay, so let's go using the method of squaring both sides. I rewrite again, 2x plus 3 greater than 5 using the distance definition. So 2x plus 3 squared, square root greater than 5, and then squaring both sides. So we have 2x plus 3 squared greater than 25. Expanded, we have 4x squared plus 12x minus 16 greater than 0. Simplify, x squared plus 3x minus 4 greater than 0. Factorize, we'll have x plus 4 and x minus 1 greater than 0. The critical values again are negative 4 and 1. Now I'm going to sketch my quadratic graph. Okay, the smiley one. And then we have here negative 4 and 1. Okay, highlighting my last inequality. Okay, I want it to be greater than 0. Okay, greater than 0 means I'll take the one above the line. So we have two answers here. So in interval form, I'll take it as from negative infinity until negative 4, open. And the other one is from 1 until infinity. The same answer, but in different forms. Okay, so we are done with the example 4. Now going into example 5. Okay, example 5. By using definition, modulus of x less than a, these are only the definition of absolute value. So, and actually this type of question, we cannot use squaring both sides, okay? So that's why they ask us to use definition. Okay, so now let's not wasting any time. I rewrite the inequality, okay? X squared minus 5x plus 3 less than or equal to 3. Okay, so since this is GOAL less than, meaning that we have to use AND. Okay, I separate these two and I should use AND. Okay, so the first one will be the positive. So x squared minus 5x plus 3 less than equals to 3. The other one is negative x squared minus 5x plus 3 less than or equals to 3. So I'll solve the first one, the left one first. Rearrange it. I'll get x squared minus 5x less than or equals to 0. Okay, factorize x minus 5 less than 0. Again, a quadratic inequality. So my critical values are x equals to 0 and x equals to 5. Okay, so we have here quadratic inequality. Earlier, we have only linear. This one is linear inequality. So we do not have to sketch the quadratic graph or anything. Okay. But in example 15, the one we got here is a quadratic inequality. So here, to solve the first one, we have to use a graphical method. Okay, we have the critical values already. Then we'll sketch the smiley graph 0 and 5. So here I highlight here first, which I have less than 0. So I have to take the one below the line. Okay, so below the line is here. So the answer for the first inequality is actually 0 and 5. Okay, so this will be the first one. So next, the second one, I'll multiply both sides by negative. So x squared minus 5x plus 3. Change the inequality sign. So greater than equals to negative 3. Rearrange x squared minus 5x plus 6 greater than equals to 0. So again, this is a quadratic inequality. Factorize. We will have x minus 2 and x minus 3 greater than equals to 0 with the critical values are x equals to 2 and x equals to 3. Okay, highlight the last one and then sketch the graph. Two and 3, we want the greater than 0, so the one above the line. So we have here the answer from negative infinity up till 2 and also 3 up till infinity. So we have two answers here. We don't want these two answers, but we need to combine. So because earlier we separate them and now we need to combine them using a number line. Okay, so please combine them using a number line. So earlier we separate them, now we need to combine them together. Okay, so we draw a number line. Okay, number line. So we will put in all the critical values we have earlier on. So we have 0 and please keep it in order. Okay, 0, 2, 3 and 5. So the first one, 0 to 5, we'll draw this one first, 0 to 5, also from 0 up till 5, and it is closed, okay, closed interval, so it is a dense circle. So this one is the first answer. Okay, so the second one, this one. This is the second answer for our second inequality. So we should put it in the same line. Okay, I'll be using different colors so that you can see. Okay, so from negative infinity up till 2. Negative infinity up till 2. And then circle. Okay. And then in the same straight line, we have from 3 up till infinity. Okay. See, the red line is for the answer for the second inequality. Although it is two answers, but they are combined together. So we have to sketch it in the same line. Okay. But not in the same line as the first one. Okay, now we are done combining. So using AND here, and mean intersect. So we have to find lines which are intersecting each other. So first is here, and the other one is this one. Now we just need to take out the answer. Okay, so the answer should be in interval form. It should be from 0 to 2 closed, and that the one is from 3 to 5. So when we have more than one interval, so how to combine them? Just put a union. Okay, and then we are done. This will be the answer. So if you want it in solution set, It will be x. So the first one is x between 0 and 2 inclusive, or another one is between 3 and 5 inclusive. So that's it for this third part. So we'll meet again in the last part, 4 of 4. Thank you.